Hi folks, and welcome back to Math with Captain Rod. I'm making this video here to help demonstrate how to use algebraic substitutions to solve algebraic equations. So I've got three examples we're going to look at here, starting with this one. All right, so this x to the fourth minus 13x squared plus 36 equals 0. So this thing is a fourth order equation here, so we can expect up to 4 solutions. One thing to notice is that x to the fourth is equal to x squared squared. So a substitution that will transform this equation into something that might look a little familiar, let's see, might look something like this. How about we're going to let z equal x squared. Now yz doesn't matter, you can use any variable there you want. You could say let y equals x squared, let u equal x squared. I like to say z. So if we let z equal x squared, this will become a z, and this will become a z squared. So our new equation is going to be z squared minus 13z plus 36 equals 0. So now what we have is we have a quadratic equation here. Now this can be solved either by factoring or the quadratic formula or completing the square. Quadratic formula is my kind of go-to, but I will kind of inspect it here and just see if it'll factor easily. So products of 36. Let's see, 6 and 6, 12 and 3, I believe. Doesn't really look to me like that's going to factor. Oh, 9 and 4. Okay, yeah, I think this thing is going to factor. So let's go ahead and factor it. This will factor into z, I believe, minus 9, z minus 4. All right, now we have the product of two things equaling 0, so either z minus 9 is equal to 0, or z minus 4 is equal to 0. It's a minus here, taking these one at a time. Z equals 9. So z, oops, I guess we'll just stop at that, or z is equal to 4. Now remember, z is not what we were after. We were after x. So now we have to kind of back substitute. So remember, z is equal to x squared, so this equation becomes x squared equals 9, and this has two solutions. X could be plus or minus 3. This one is going to be x squared equals 4. This has two solutions. X could be plus or minus 2. And here's our 4 solutions, and this problem is done. You could check them by taking any one of these and plugging it in for x here and making sure you get 0. Let's take a look at this one. If you don't mind, I'm going to, whoops. At least I think I'm going to try to move this whole thing to the right here. Give me just a little more room. All right, so let's take a look at that. Now, this square root of x, the power on that x is actually 1/2. And then this is x to the first. So this is equal to this thing squared. So another, a good substitution here. We're going to do this again. Let z equal square root of x, or you could write this x to the 1/2. Those are the same thing. And now this is going to become 2z squared. That's going to be 2z squared minus 7 times z minus 30 equals 0. So what we have now is another equation here that's quadratic. And I think on this one I'm going to go ahead and use the quadratic formula to solve it. So z is going to be the opposite of b, would be 7, plus or minus the square root of b squared. So that's negative 7 squared. Let me write that a little better. Minus 4 times a times c, oops, all over 2 times a. All right, cleaning this up a little bit. So that's going to be 7 plus or minus All right, square root of, so that's going to become a positive 49. And what do we have under here? 8 times 30. Oops, 8 times 30 is 240, I believe. Minus and minus is a plus, so that's why that sign is positive. All right, so that's all over 4. So now we're going to have z equals 7 plus or minus. All right, so give me a moment here. If you take this thing and simplify it, we get 289 under here, square root is equal to 7. So we got 17. So we got 7 plus or minus 17 over 4. We're getting there on this one. So we have two solutions. One of them is 7 plus 17 over 4. That's going to be 24 over 4, I believe 6. Or z is equal to 7 minus 17. That'd be negative 10 over 4. Or negative 5 halves. And let me just double check my math on these things. 7 plus 17, 24 over 4, which is 6, yep. And 7 minus 17 is the negative 10 over 4. I think we're looking good. Now, we're not quite done yet because it wasn't z we're after, it's x. So keep in mind that z was square root of x. So this one becomes square root of x equals 6. This is solved by squaring both sides, so x is equal to 36. Other possibility, square root of x equals minus 5 halves. Now, this equation, right, when you square root something, this is called a principal square root. When you square root something, it has to be positive, or the principal square root is positive, so there is no solution attached to this one. So there's our only solution to that equation. All right, there's example 2. Let's work on example 3. And I am going to, again, I want to make myself some more room here to work. I think I'll just, oops, shrink that stuff down and move it over. All right, let's see what we can do with this one. I would say let's start by something like, let's let z equal 1 over x, right? Because this is x to the minus 1, or this is 1 over x, and this is 1 over x squared. So that's going to become a z squared minus z minus 6 equals 0. Boy, we ended up with another quadratic. This one is screaming factor. Let's see. Products of 6, how about minus 3 and plus 2? That gives us what we want, z squared plus 2z minus 3z. There's my minus z and then minus 6. So this one's good. All right, so one possibility, z equals 3, or the other possibility, z equals minus 2. Now remember that z was 1 over x, so 1 over x equals 3. So 1 equals 3x, x equals 1/3. There's one of our solutions. 1 over x equals minus 2. Multiply by x, and this is going to be 1 equals minus 2x. Divide by the negative 2. X is minus 1/2. So, okay, we're at over the 9-minute mark on the video, so this thing's plenty long. So, the purpose of this video was to try to demonstrate how to use algebraic substitutions to turn kind of complicated equations like this into things that are less complicated that we can deal with. In this example, we ended up with 3 different quadratics and got these equations solved. Just don't forget that when you make an algebraic substitution such as this, and then you solve for your variable here, you still have to back substitute to the original, which is x. So I'm going to go ahead and end this video here. I hope that this helps. Have a great day.